Welcome back to the deep dive. So today we're looking at a pretty critical piece of broadcast gear, the Thor Broadcast F-8ASI. Now uh, it's more than just a media converter. It's really this necessary technical bridge, solving the physics problem of moving huge video streams over some serious distances. Let's unpack this.
Exactly. And our mission today is really to get past the data sheet, to understand the real world impact. We're looking at how this copper to fiber media adapter takes a high quality video stream.
Well, they'll normally just die out after a few hundred feet.
Right. And it turns it into a signal that can travel over 100 kilometers.
Yeah.
And it handles the big industry standards, DVB, ASI, and even standard F-SDI.
Okay, that dual capability, that's got to be a big plus for flexibility. But let's talk specifics. I mean, everyone's pushing IP gateways now. Why does dedicated fiber like this still matter so much? We're talking about the F-8ASI converting the transport stream into an optical signal. What does that actually enable at scale?
Well, it enables scale without the usual headaches. So no compression, no major latency issues. You're getting 8 fully independent channels. Think of them as 8 distinct pipes.
8 pipes, got it.
And this unit supports speeds up to 622 megabits per second.
That's a ton of bandwidth.
It is. It's the kind of volume you need for, say, multiple uncompressed HDTV feeds or high-volume video on demand. It meets all the SMPTE specs, so it's ready for any professional environment.
So it's not just a raw number for throughput. It's the guarantee of handling 8 separate high-quality streams reliably. And that reliability has to extend to distance, right?
Yeah.
That's the whole point of fiber in the first place. So what's the actual technical achievement here, the long-haul capability?
Oh, the leap is monumental. I mean, with copper, you're lucky to get a few hundred feet. The standard range for the F-8ASI is 20 kilometers.
20 kilometers is already huge.
But the unit is engineered to go all the way up to 120 kilometers over single-mode fiber.
120. Wow.
Yeah. And it does that using just a single strand of fiber, which, cuts down on your cabling infrastructure quite a bit.
That 120-kilometer range is what lets broadcasters build out these massive consolidated network hubs. Okay, let's look at the hardware. On the copper side, it's 8 BNC connectors. That's standard everywhere. But the optical side, you see options like SDPC, SCPC, or even FC. Why so many?
The physical connections are, they're critical for signal integrity. BNC is universal, like you said. But the different optical connectors, they matter for specific needs. For instance, that SC-APC option is key if a facility needs extremely low signal reflection.
Which means a cleaner signal over those massive distances.
Exactly. And it's also built to be simple. It's plug and play, has diagnostic LEDs on the front. You know immediately what's going on.
Okay, so with this level of engineering, for this scale and distance, the big question is cost. This isn't a consumer device.
No, not at all. This is core infrastructure. It's built for critical 2047 service. You're looking at a price point right now of about $8,995. It comes with a 2-year warranty.
And it has all the regulatory approvals. I see FCC, CE, UL.
All of them. So it's cleared for deployment pretty much anywhere in the world. It meets all those rigorous safety and industrial standards.
So to sum it up, the Thor F-8ASI is essentially this incredibly robust 8-channel bridge. It moves your copper-based broadcast streams directly into the ultra-long-distance world of fiber. And it keeps that signal perfectly intact across 120 kilometers.
Right. And if you think about the broader picture here, something to leave you with, the F-8ASI is purely about raw transport, getting that light from point A to point B. But this product line also has things like the H-8ASI MUX, which is a multiplexer, or the H-8ASI IP, which is an IP gateway. So we know this box solves the physics of distance. But how do you decide between this kind of simple direct fiber transport and the trend of sending everything over a managed IP network? What's that trade-off between dedicated light versus packet switching? Something to really think about as you plan your next infrastructure upgrade.